Hello everyone, welcome to Durham College e-learning platform. Myself Biponshi Borah, a faculty member in the Department of Statistics at Durham College. Today, I'll deliver a lecture on skewness and kurtosis. As you know, in today's world, data is becoming increasingly important. Entire professions are dedicated in studying, understanding, and manipulating the data. Hence, it is important to know the different types of data and their associated properties. So, in this session, we'll discuss how to calculate a distortion in a normal curve using skewness and kurtosis. So, let's get started. Skewness is a measure of symmetry, or more precisely, the lack of symmetry. A distribution or data set is symmetric if it looks the same to the left and right of the center point. Here, this is positively skewed distribution and this is negatively skewed distribution. Kurtosis is a measure of whether the data are heavy tail or light tail relative to a normal distribution. The definition of skewness. Skewness refers to a distortion or asymmetry that deviates from the symmetrical bell curve or normal distribution in a set of data. If the curve is shifted to the left or to the right, it is said to be skewed. Skewness can be quantified as a representation of the extent to which a given distribution varies from normal distribution. A normal distribution has a skew of 0. So, this is the symmetrical distribution in which mean, median and mode are all equal. There are two types of skewness. Number one, positive skewed or right skewed distribution, or negative skewed or left skewed distribution. So what is positive skewed or right skewed distribution? In which most values are clustered around the left tail of the distribution, while the right tail of the distribution is longer. In positively skewed, the mean of the data is greater than the median. Actually, a large number of data pushed on the right hand side. Here, the mean, median, and mode of the distribution are positive rather than negative or 0. So, what is negative skewed or left skewed distribution? In which more values are concentrated on the right side of the distribution, while the left tail of the distribution graph is longer. The mean of the data is less than the median. Actually, a large number of data pushed on the left hand side. So here the mean, median and mode of the distribution are negative rather than positive or 0. So, how we calculate the skewness coefficient of the sample? Here, the Pearson's first coefficient of skewness is given, mean minus mode divided by standard deviation. So it is truly scales the value down to a limited range of -1 to +1. Here, the Pearson's second coefficient of skewness, 3 minus 3 into mean minus median divided by standard deviation. So if the skewness is between -0.5 and 0.5, the data are nearly symmetrical. If the skewness is between -1 to -0.5, this is also called negatively skewed, or between 0.5 and 1, which is also called positive skewed. Here the data are slightly skewed. If the skewness is lower than -1, which is also called negatively skewed, or greater than 1, which is also called positively skewed. Here the data are extremely skewed. So what is kurtosis? Kurtosis is a statistical measure whether the data is heavy tail or light tail in a normal distribution. Kurtosis tells us about the peakness or flattenedness of the distribution. Kurtosis is basically a statistical measure that helps to identify the data around the mean. There are three types of kurtosis. Number one, leptokurtic, which is also called habitable distribution. Number two, mesokurtic, which is same as the normal distribution. Number three, platykurtic, which is also called short tail distribution. So the definition of leptokurtic, where kurtosis is greater than 3. Leptokurtic is having very long and skinny tails, which means there are more chances of outliers. Positive values of kurtosis indicate that distribution is peaked and possesses thick tails. An extreme positive kurtosis indicates a distribution where more of the numbers are located in the tails of the distribution instead of around the mean. So the definition of platykurtic, where kurtosis is less than 3. Platykurtic, having a lower tail and stretched around center tails, means most of the data points are present in high proximity with mean. A platykurtic distribution is flatter when compared with the normal distribution. So the mesokurtic curve, here kurtosis equals to 3. Mesokurtic is the same as the normal distribution, which means kurtosis is near to 0. This is a mesokurtic curve, which is same as the normal distribution. In mesokurtic distribution are moderate in breadth and curves are medium peaked height. So this is the leptokurtic curve, this is the platykurtic curve, and this is the normal distribution curve. Thank you.